Good evening, folks. It's, what, 9's... Oh, never mind. It's 10 o'clock already. Watch me do some lithography using just 3D software. I created this mask right here, and it's based off of an experiment that we're doing in the laboratory pertaining to tunneling junctions, or should I say magnetic tunneling junctions. And I made these 3D models based on that, and that's what it looks like under the microscope. I don't have the final image here, but this is what the device basically looks like. It's connected to these metal contacts for measurement, magnetic resistance, coercitivity, and so forth. And so I'm going to do this top section here, and I'm basically going to do what we do inside the laboratory. So we take a mask, we place it on top of this substrate like that. We flip it over. Okay, well, actually I'm going to increase the thickness of this mask right here that I created, and we're going to turn it into a hole so we can make an extrusion, and that extrusion is going to represent the ultraviolet light that's being rained upon. I should have a diagram showing that here. Is it this one? Nope. Is it this one? Yep, right there, that one. Maybe I should increase the size a bit on that. So this is basically what's happening. It has this ultraviolet light, and it's shining down on this mask, these patterns, onto the substrate, and the substrate has this layer that can be eaten away by the light, basically, or etched away by this ultraviolet light. Okay, and after that's done, we do that, let the ultraviolet light shine through it, quote unquote, and then we're gonna do, let's see, oh, it's a hole already, and we're going to do a full selection like this. Do a group, and boom, we have created a layer that we can work with here. And we now have separate pieces on this side, and you can see the different layers that can be used for making contacts right here. Then you can apply these 3 layers to measure on the tunnel barrier. And we can apply a current between these 2 electrodes right here, and then these 2 electrodes, these 2 electrodes and these 2 electrodes can be connected to the other 2 barriers, so that we can measure the magnetic resistance and other phenomenon, quantum phenomenon, like the anomalous Hall effect and other things like that. You can take it. You can either do this at room temperature for a certain magnetic resistance, or you could take it up to, or take it down to rather, lower temperatures, like maybe say 10 degrees Kelvin down to like 4 degrees Kelvin, Bose-Einstein condensation, and you can make some measurements with that. And just to give you sort of an idea of what those measurements might look like, you have that coercitivity that I was talking about right there, these graphs. Okay, thanks for watching, folks. Just wanted to show you that. Cheerio.